Hey guys, look, a submarine. Oh no!
How did this happen?
Boyle's Law.
What's Boyle's Law?
Robert Boyle was an English chemist who was born in 1627. In 1661, Boyle did an experiment with a J-tube, where he trapped oxygen inside of a tube by plugging it up with mercury. By expanding and contracting the mercury, he could increase and decrease the pressure within the tube. Boyle noticed that the product of the pressure multiplied by the volume was constant throughout the experiment. No matter how high or how low the pressure and volume were, they would equal the same number when multiplied together. This inverse relationship between pressure and volume is called Boyle's Law, and is represented by these two equations here, where P equals pressure, V equals volume, and K is a constant value. The units for pressure is atm, and the units for volume is liters. For Boyle's Law to function properly, you have to make sure the temperature remains constant. A real-life application of Boyle's Law is car tires. The more air you put in the tire, the lower the volume becomes. At the same time, the pressure increases, so the relationship between the pressure and the volume of the air in the tire is inversely related, and can be seen through the expansion of the car tire and how hard it is to push the tire in. Another example in real life is in submarines. As a submarine sinks below the water, the volume and air pressure of the submarine stays constant. On the other hand, the pressure on the outside increases over time. The pressure on the outside presses itself on the submarine, which is why deepwater subs are made out of such heavy-duty materials, and also why the Titanic submarine imploded. The last example in real life is a balloon. When a balloon is inflated with normal air, the pressure inside the balloon is naturally higher and the volume is lower. If you squeeze the balloon enough, it will increase the pressure and decrease the volume to an extent that can eventually result in the balloon exploding. Let's do a problem involving Boyle's Law. Let's say that the pressure inside of a balloon is 1.7 atm and the volume is 635 liters. If someone squeezed the balloon and the pressure inside became 3.2 atm, what would the volume be? First, let's look at our equations. We have both the initial pressure and volume as well as the pressure after the squeeze. Therefore, all we need to do is fill in the information we have and solve for volume by filling it in with x. Doing some basic algebra, we can figure out that x equals 359.33. Therefore, the volume inside the balloon is 359.33 liters. Here's a problem for you to try. Let's say that you're suspicious that you have a flat tire but don't quite know yet. Let's say that you know that the pressure times volume value, or K, is 1,723. If you know that the bare minimum pressure you need for your car tire to function properly is 1.36 atm, then what is the highest volume of air that you can put into your tire? First, let's get a basic idea of what we need to do. Since we're looking for the highest volume we can put into the tire for it to work, we need to know what the minimum pressure required for the tire to work is. Remember, Boyle's Law is an inverse relationship. Since we have the minimum pressure, which is 1.36 atm, we can fill in x for the volume and say that 1.36x equals 1,723. Finally, to get the value of x, we divide 1,723 by 1.36 to get 1,266.91 liters. Overall, Boyle's Law is an essential chemistry concept to understand because of its modern-day importance. Boyle's Law is the reason why your car can use its tires, and it's also the reason why submarines can function. We have a lot to owe to Boyle's Law, and now I hope you have a better understanding of it. This has been Lane Cook, and thank you for watching.